Right, my name is Garrett Foster. I am a senior security researcher over at on the team at SpectropOps. Been there a little over 2 years. Kind of like my day-to-day responsibilities there are to do a bit of tradecraft discovery and red team enablement. So kind of like if you're at a stuck point, my goal there is to help them get through that stuck point, and then whatever the results of that research, we try to take those results and then implement them in our product, the Bloodhound Graph. I don't have a ton of time, so I'm just going to press on with the agenda. So what I hope to share with you today is a bit of a recap on what SCCM is and kind of do a very quick explanation of where it is, where it came from, and then some of the security research that has been done by us and the community as a whole. And then from there, we'll talk a bit about co-management. So if you have an Active Directory environment that is hybrid and is using Entra as well for some type of identity management, co-management might be relevant. And then we'll talk about the Administration Service API, which is an on-prem API that grants kind of like this administrative access to SCCM. So it's just another way for admins to be able to administer that service, but it's going to be relevant to the co-management piece. And then we'll finish things off by taking advantage of all of that co-management to go from a low privilege user context to completely taking over all of SCCM and therefore all of the managed clients in that service. So SCCM stands for System Center Configuration. I lost it. Where'd it go? Okay, so System Center Configuration Manager, SCCM. It's gone through a bunch of different name changes. It's about 30 years old, so it's been recycled a bit. I'm a little bit more partial to this beautiful piece of artwork by my coworker Craig, because it's now known as Microsoft Configuration Manager. Just like the quick recap, this graph was made by Carson Sanker. He made a blog post a couple years ago kind of detailing how we got to where we are now. So SCCM was first introduced in about 1994, and it didn't really get into much offensive attention until DEF CON 20, when Dave Kennedy was presenting on how he was able to leverage that service to basically pop shells on every client. So at its core, SCCM is just endpoint management software. It'll have an agent running on whatever hosts are being managed by that device. It has system level access because it's responsible for driver updates, Windows updates, application deployment, and like policy deployment. So Dave took advantage of that and realized that if you could just take over SCCM, you therefore control every client. And the research kind of continued from there. Matt Nelson, one of our coworkers, he kind of picked it up and ran with it a bit, had a few blog posts and tools. And then it died for a number of years, and then Chris Thompson and Dwayne Michael kind of picked up the baton and kept that going. And the last few years, it's kind of exploded from an offensive point of view, and it's exploded so much that myself, Dwayne Michael, and Chris Thompson developed this kind of living document called Misconfiguration Manager. It's a GitHub repository that tries to take all of the known offensive tradecraft and gives it a taxonomy. So if it is a takeover, or you're able to grab credentials from it, we label those and we outline how the the attacker can take advantage of that while also supplying like defensive measures that the defensive team can take. So it's good for both sides, both red and blue. But since then, there's been a number of like community contributions, and probably the most notable has been from the Synactive. They're a team over in France. They found an unauthenticated SQL injection that led to complete compromise from an unauthenticated perspective to control all of SCCM and then therefore every client. That's not really it. There's been a number of different like community contributions, whether it be blog posts or tweets or tools or just conversations about how they have used this service to accomplish some level of goal or objective during their assessments. But the point I'm trying to make is that we have focused so much of that effort to only what's on-prem, like we only what's ever in the enterprise network. But it was time to explore how it would work when you are integrating your on-prem, you have a hybrid deployment with the cloud, particularly with Entra or Azure or whatever they're going to name it next. So there's 3 ways that SCCM can actually have this hybrid or co-managed deployment. The first is tenant attach. This is less of a expansion, it's more of a like DLC for SCCM. So there's a couple extra pieces you can do from Entra. But the 2 that are most relevant are the cloud management gateway and then co-management. And both of these are 2 different deployments, but both solve the same problem of managing a remote workforce, which over the last few years has been kind of an explosion. So the Cloud Management Gateway, or the CMG, the way this process works is you'll have a virtual machine hosted up in Azure that your clients, your remote clients, will connect to, and it basically proxies that connection into your physical network. So this is used when they can't have VPN access, they're not in office, they're across the globe. They can connect to this endpoint to have policies applied and so on and so forth. So on the other side of that is co-management, a little bit different. This is actually going to integrate with Microsoft Intune, and Intune is Microsoft's cloud endpoint management solution. So the way this works is it just kind of integrates and you pass off workflows between the two depending on what your requirements are. But the lines do cross a bit, and it's due to how are the configuration requirements for setting up both those solutions. And you'll do so from within the Configuration Manager console, and you'll set up what's called Configure Azure Services. And the piece that you'll be doing is called Cloud Management. And the wizard is actually, it's relatively easy, it's streamlined, there's not a whole lot of nuance to it, so we don't have to spend much time on it, but the key piece that you're doing is you're setting up two Entra applications. There's a client app and a web application. And these work together to create an OAuth flow for users to sign into to this specific scope. If you scroll down a bit, there is a kind of a key thing that you might overlook. There is the option to disable Microsoft Entra ID authentication. So if you were just skimming through this and weren't paying attention, you might have missed this, but that implies that Microsoft Entra authentication is enabled by default for the tenant, regardless of how you're setting things up. So once that completes, we don't have a lot of visibility into what those applications even are or what permissions we're granting it, because we're setting them up with global admin or cloud application admin level permissions. So let's take a look at what's actually happening. We have the client app, and it is being delegated user impersonation to the web app and whatever that is scoped towards. And so this is pre-consented, so the user that's being impersonated does not have to approve it. And this will happen for any identity that's in Entra. From the app side, what we're actually accessing, what's being granted to us, is we have this API URI. But we didn't actually set any type of backend up for this, and this is where the admin service comes into the picture. So the administration service is that on-prem OData REST API, and it's hosted on the SMS provider role. The SMS provider, let's see if I can get this, provides API interoperability access over HTTPS. So the SMS provider actually contacts the database through WMI. So what they did is to grant you API access to it. They just put an API in front of WMI, so you have another layer of abstraction. But it gives you administrative access from this perspective. And that is implemented, if we take a look at the service binaries, we can see this URI exists, that admin service URI is present. And this is relatively well known if you've been ever messed with SCCM. There's tradecraft around this, there's post-exploitation that's been taken advantage of here. But when you look at the source code, because it's all in .NET, so we can reverse it, there's a completely different URI path that I really wasn't aware of that seems relevant to Entra because of the token auth string included in it. So if we keep kind of digging into that source code and see what's actually being implemented by the service, it is handling any type of CRUD operation being submitted to that API. So if you're trying to make some type of change or you're trying to recover data, it's going to process that request and kind of pass that off to the WMI endpoint. So there's a few checks. It's going to instantiate a new Windows identity class, a C# class, and this just represents a Windows user. So we'll just kind of have that ready to go and usable. And then from there, it's going to check and see, is Azure AD enabled, or Entra, now that we've changed things. And we know this has been enabled by default. So we can kind of press on through that logic and hit this method called parse bearer token. Now this method is going to take whatever was in the authentication headers for that API request, pass off that token to this method, and that's where the fun really begins. So it seems like it might be a simple a process to parse this bearer token, but you'd be mistaken. It's about 15 layers deep of different kind of poking and prodding to make sure everything's in line. But the end result is it's doing two things. It's validating the token signature. It's making sure that the token that we are providing is coming from where it says it comes from and that it hasn't been manipulated in any way, that we didn't try to change any strings or any values in it. So the signature for that is still good. And then it's just going to validate the token's issuer and audience. Those two strings are like the big piece to the puzzle. And that's arguably the only interesting piece from all of that, from the whole flow of validating this. And it's stored in the get authentication info method. So what we'll do is we're going to build a list of issuer, audience, a metadata, and a signing cert. So how do we get that data? Where is that stored? SCCM, essentially everything lives in that database, is in the site database. You can consider that the brain of the entire operation, and then the site server itself is the body for everything else. The way it pulls that data from the site database is it runs a stored procedure, which is, you could think of it as a script to run SQL queries. And that stored procedure is called get token validation info, and the result of that, if we take that syntax, since it's a test environment, we can take it to the site database and issue that or run that stored procedure to see the data that's being returned during like standard operation. So we'll get an issuer, audience, the metadata, and then the signing cert. So the piece that's relevant to validating this token are, you're going to take the string value of the issuer and the string value of the audience. You'll have your bearer token. You'll deserialize that, and then it's just doing a one-to-one string match for both. It's saying, are they equal? Is it 100% accurate? And that's the validation steps. That's it. We want to make sure it's signed and make sure that these two strings match. So cool, we've made it back up to the parse bearer token method. We're saying, hey, cool, here's your validated token. Go ahead and press on with processing that request to transform it to WMI and keep going. And that's when we get back to our Windows identity. So we're going to instantiate the Windows identity and store it in this identity variable. And we're going to pass it the user principal name value from that Entra token, our validated token. So the UPN is a claim included in this, so we can pull that out and actually extract the domain user UPN from the token. So now we pass it off and we created this class as this user. So if you look how the Windows identity class operates, when we overload it with just a user principal name value, it's doing one thing. It is going to call, it's going to construct it by calling the curb s4u logon structure. So if you're unfamiliar, a curb s4u is a Kerberos extension implemented by Microsoft called Service for User or Service for User to Self. So that service is going to create an impersonation token on that endpoint as that user. So domain user is now impersonated, and it's saying this is the identity that I'm going to process the request for. So I stewed on that a bit and was kind of curious, like, okay, so it's just doing this s4u logon. This kind of makes sense. Like, what's the actual inherent risk here? And this is kind of my experience on how this went down. And the conclusion is that the admin service impersonates any UPN from a validated token. There is no authorization checks being done whatsoever. So if there is some way that we can manipulate that value, if we can push a UPN for a known administrative user into Entra and authenticate as that user, we could be admin. And it sounds too easy, and it is, because there's some nuance to how UPNs, or user principal names, work in AD and Entra. So here we have a BSides user, and it has a user principal name value. So when you have a hybrid environment, typically what will happen is you'll have users that are synchronized into Entra, and you can have some control, like you might be able to specify a certain container or a certain list of users that are synchronized. But for the sake of argument, let's just say that every user is synchronized. And there are a few attributes that map automatically when a new user account is created in AD, and then that transfers into Entra. And the user principal name is one of them. So if we have BSides PDX at unsigned short, we'll see that once that user is created and synchronized with Entra, the UPN follows it. It goes with it. So this attribute being present is called explicit UPN mapping. Because it's present, it's actually stored in that attribute, it's explicit. But what about the case where there isn't a value present? Like, what happens there? Microsoft considered this, and they explained the process when that value isn't present. And the quote is, a UPN can be implicitly or explicitly defined. And an implicit UPN is always associated with the user's account, even if an explicit UPN is not defined. This is also true when it is. So you could think more of an explicit UPN as an alias. If your internal domain name is different from the UPN value that's present, no matter what happens, during the authentication process, your implicit UPN is the context that you're authenticated under. So MS Kyle actually explains how this process happens and where the implicit value comes from. It will concatenate the name with an @ symbol followed by the DNS name of the domain. So it'll just kind of build all of that together and combine them. So from our example user, it'll take the example, add the at unsigned short, and there is our implicit UPN. Things get interesting when we start to think about machine accounts. So the site server I mentioned you can think of it as the body of the entire thing. And from all the tradecraft that we've had for compromising SCCM and using it to kind of take over environments, the site server is the #1 target. It is a ton of responsibility in SCCM. It is admin on all of the certain roles. It's responsible for maintaining the health of things. But what's good in our situation is machine accounts will not have a user principal name mapped by default. When you create a new user account, typically you're going to create a username, and AD will automatically populate that attribute. If you try to nullify it or remove it using their tooling, you'll get a constraint violation. And then you also have a scenario where UPNs are required to be unique across the forest. So thinking of scenarios where, okay, what if we could just take a admin's UPN, add it to a user that we control, and take that route, you'll run into constraints. But the way the implicit UPN works for a site server, or for any machine account, is it's going to take that name, concatenate it with the @ symbol, and then concatenate it with the domain name. So we can create an implicit UPN for that user. So if we own any user account, or if we own some type of privilege to modify the UPN value of a user, we could change it from whatever value it is to the explicit value of the UPN and not run into a constraint violation because it's not there. So let's look at what that process might look like. So through this, we'll go through, we're going to look at the BSides users' privileges and their their settings. It has the explicit UPN map to @unsigned short. So we control this user. We can flip the UPN value to the site server's UPN. So now we have an explicit UPN that's mapping to that. From there, we can now authenticate as the BSides user with our new UPN, which still ties to us. So I've already synchronized it, so it's already up in Entra. And now we have a token with that UPN value present. So now we'll remove that explicit UPN. So if it tried to map the identity when we use the token, it would hit that account. But now that it's dangling, it's going to resolve the identity to the site server. So here's us in the administrative console showing that we have just one singular admin, and then we will run an API request using that bearer token and then submit it to the API. And we'll go through that validation flow that we've seen, where it just it deserializes it, validates everything, makes sure that the strings match, that the token signature is good. But because we've impersonated and we have that UPN value of the site server, it will immediately add our user as an admin because it is impersonating itself at that point. So we play with the logic flow there. So we thought this might be bad. Disclosed it to Microsoft in July. After some back and forth, they decided that it was going to be an issue that would be patched. They assigned it this temporary or this potential CVE. It's still tentative. The patch was supposed to be released today. It wasn't, but they told me that we could release it today. Like this was the timeline. So, so here we are. But yeah, that was essentially, this was a public disclosure for that. I have about a minute left in the talk. So are there any questions, curiosities, or anything there?
What kind of assets would we expect to see that CVE on if we ran a tenable scan?
If you ran a tenable scan right now, I don't expect you to find anything yet.
If it was.
Yeah. That's a curious one. So you asked if the question was like, what kind of assets would we see this running on if we were run a tenable scan? You'd have to have your scanner running probably on the site server itself to have some type of access there, and as well as so the cloud management gateway. I only have 20 minutes. There's more to this. The CMG is hosted in Azure, and you can actually expose that administration service API to the internet. Like that's a feature, and so now that tells us that if I get access to Entra, I can just create that token and authenticate to that API, and now have control of your whole on-prem without ever actually being on-prem. So.
What if somebody was cloud Entra only? Was
Entra only? It's gonna more than likely you'll want some type of access to the site server still, because that's the end game. Is getting control of that on-premises asset that has all of the clients and managing all the different resources throughout there. Because we're basically creating a hybrid attack path there where we can go from the cloud to on-prem, and now we control everything that has an agent installed on it, whether that's on-prem, remote, cloud, wherever. It's going to be environment dependent and deployment dependent. So I mentioned those three different types of doing co-management. If you're using the co-management version where you're integrating the two services, you'll probably run into where this might be a leverage for that. Any other questions? If there's not right now, I'm going to be kind of hanging out in the hallway or probably run over to our booth. But thank you so much for attending. I appreciate it.